Okay, so here we are on to Chapter 6, Section 2, Fractions and Literal Numbers. So we're continuing to build on the information that we've learned in the previous sections using prime factors and common denominators and common multiples, and continuing to learn how to use our operators, add, subtract, multiply, and divide on these fractional values. Okay, the objectives, factors, common denominators, operators. So if we take a look at this, literal numbers are prime factors when they are raised to the first power, as in x is prime. But x squared, which is raised to the second power, is not prime. Well, why is that? Because we have two separate values in here. If x was 5, that would be prime. If x squared, if that were 5 squared, that's not prime because we have two powers, a power there of 2 operating on the 5, so it gives us 25, and that can be factored down. So as we look at the terms here for prime factors, x cubed, y squared as an example, we can see we have 3 x's and 2 y's, okay? In the example here, 40a squared b cubed, we have 2 times 2 times 2 times 5 times a times I. Okay, so all of those can be factored down to their primes. Okay, by themselves, they are not primes. So the rule states that to find the lowest common multiple of numbers containing literal numbers, i.e. those variables, factor each term, determine the maximum number of times the prime factor appears in one term, and then multiply the resulting prime factors found in step 2. So we've done this before, but now we're doing it with variables. So if we look at an example here, 6a. 6a has 6 times 3 times a. Each one of those is now a prime factor. 18a squared. 18 is 2 times 3 times 3, a times a. Okay, so with that, we could determine the lowest common multiple for those two numbers. Okay, so now let's take a look at putting it back together. The maximum number of times the 2 appears is 1 time in each. Okay, so we're good to go there. The maximum times the 3 appears is twice in the second term. And the maximum time that the a appears is twice. So if we put those maximum values together, we end up pretty much with 18a squared, okay? So that is our least common multiple. That's the value that is the lowest number that contains both 6a and 18a squared. In multiplication of monomials, to multiply monomials, we multiply the real numbers and then the literal numbers by using the laws of exponents. So in this case, the upper number, the multiplicand, 6a, we're going to multiply it by 7a, the multiplier, and we end up with a product of 42a squared. The product cannot be simplified farther because we have not given a value to a. Okay, so that's as far as we can solve this problem until we give a some value. Again, recall we can use the multiplier cross, a dot, or parentheses as part of grouping to indicate operations and or multiplication. Okay, in our division of monomials, 18a by 6a gives us a value of 3. Well, in this case, the a's have canceled out. So we have no literals left. We have no variables. Okay, so we end up with just a coefficient or just a real number. If we look for the prime factors and cancel those appearing in both a numerator and denominator, we would end up with, in this case, 2 times 5, a cubed, 2 times a squared. We end up with 5a as an example. In multiplication of fractions, this is one of the easiest operations to do. So all we end up doing is we take whatever is in the numerator, multiply it. We take whatever is in the denominator, multiply it. And then you can factor to see what will cancel out. Okay, so we end up with 2 times 3 times 3 times a cubed, 2 times 2 times 2 times 5, and we end up with then a set of 2's in the numerator and the denominator that cancel. We end up with 9a cubed by 20. With division, it's just like multiplication, except we, again, invert and multiply. So 5a or 4a divided by 5 is going to be the term that we're going to invert, and then multiply. Again, we just multiply 15a in the numerator, 4 times 4a in the denominator. Again, the a's cancel out because they're common, and we end up with 15/16. In dealing with addition and subtraction, different story. We have to have a common denominator when we're adding. So in this case, this problem shows us that we do have a common denominator, 7. So we can combine the numerator, 2a plus 3a, and the common denominator of 7 to end up with 5a times 7. Same thing applies with subtraction. In this case, we have a 9 as a common denominator. So we can combine the terms in the numerator, 7x minus 3x divided by 9, and we end up with 4x by 9. So it's good to go back and read these rules to make sure we understand what the rules are telling us. But the easiest way to learn these is just by doing and practicing the procedures. Okay, if we look at an example here where we're going to add together 3 values or 3 terms that have a 20, a 15, and a 10 in the denominator. We can't add them together, so we have to start looking for our least common multiple. So 20, 15, and 10, we factor them. We look for the maximum times that the terms appear. So we have 2 showing up twice, we have 3 showing up once, and we have 5 showing up once. So when we gather those terms, 2 times 2 times 3 times 5, we end up with a common denominator of 60. So now all we have to do is we have to figure out how do we take each one of these terms that have a 20, a 15, and a 10 in it to make the denominator a 60. So we have to multiply the top and the bottom by those terms, by those coefficients that make it a 60. So in this case, if I multiply a 3 over 3, I get 60. If I multiply a 4 over 4, I get 60. And if I multiply a 6 over 6, I get 60. So now I have all of these combined together and set up with a common denominator. I can put them back together as a sum. The 60 is common, so all I have to do is gather the numerator terms, 9a, 8a, and 18a, which we solved for over here. Combine them, I get 35a over 60. I can factor out a 5 in each case, and I have 7 and 12 left, so 7a by 12 becomes the solution once we find our common denominator. It just takes practice.